Find the unknown values of y if point P has coordinates 5y, Q has coordinates 1, -3, and the distance PQ is 5 units. In this case, we do not have a diagram, nor have we been told if y is positive or negative. So let's start with the formula. PQ is 5 units, so we can make a note of this over here. And now we can fill in the rest of the formula. In the formula, we want the variable y to be positive. So let's make Q our first point and P our second. Now we can open a bracket and we say the y coordinate of P, which is y, minus -3, close the bracket, squared, plus, open a bracket, 5 minus 1, close the bracket, squared, all under a square root. Next, we need to get rid of the root. So let's square both sides. On the left, 5 squared is 25, and we make this equal to. On the right-hand side, the square and the root will cancel. Let's leave our first bracket is y plus 3 squared, plus 5 minus 1 is 4. So we can say 4 squared. Now we can expand our brackets. We have 25 is equal to y plus 3 squared, and we get y squared plus 6y plus 9. Then we have plus 4 squared, which is 16. Let's tidy up the right-hand side of the equal sign. On the left, we still have 25 is equal to y squared plus 6y. 9 plus 16 gives us 25. Again, we're working with a quadratic that we need to factorize. So let's move this 25 over to the other side of the equal sign. And we have y squared plus 6y plus 25. Then we're going to move this 25 and we get negative 25 is all equal to 0. Finally, we can add like terms. The 25s will cancel out and we're left with y squared plus 6y is equal to 0. This quadratic only has 2 terms, so the only thing we can do is to take out a common factor of y. So we can say y, open our bracket, y plus 6, close the bracket, is equal to 0. This means that y could be equal to 0, or y could be equal to -6. We have not been given a diagram of exactly where point P lies, nor have we been told if y is positive or negative. So in this case, y could be 0 or it could be -6. And this is our final answer.